Oh, hi, welcome to the fun probability problem solving sections. And today we're going to solve another very fun and famous probability problems. Is we find the probability of matching heads. So what is this problem about? So we assume a man, they come to a party, so they take off their hats and all the hats are all mixed up. So when the time they're ready to leave, they picked up the hats here, right? So that's the PN represent the probability. No man find for all this n men, no man find the match hat. So the first things we want to prove is the Pn is equal to n minus 1 to the n the Pn minus 1 plus 1 over n Pn minus 2 for the n greater than or equal to 3 here. Okay, so let's take a look here. Let's go ahead, go to our whiteboard, and let's start to work on this problem here. All right. Okay, so let's take a look at the first. Let's take a look at for the matching head, the total case, the total number of the case. That will be our denominator, right? So the total number of the cases here. Since I have n mans here, right? So this is the total is n man. So when the first person choose the hat, this person have an n chance to pick up any hats. After this one pick it up one, so the second person has n minus 1, n minus 2, dot, 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 dot to 1. So the total case is pretty simple. It's n factorial. Correct? Okay, so this is our total cases here. Okay, so now let's take a look at the PN3. In order to do that, let's start out with P1. Okay, so let's take a look at P1. Okay, so for the P1, that means I only have one person comes to the party, right? So you only have one hat. So what is the chance for this person pick up the wrong hat? It's 0, right? Because there's no other people there. So the P2s here, that means I only have 2 people come to the party. So for example, A and B here. So in order for the P2, that means both people pick up the wrong hat. That means when the A choose, we have 2 hats here, right? So let's say this is hat A and hat B here. So when the A choose the hat, in order to be totally not matched, A has to choose what? A has to choose the hat B, right? So what is the probability here? So the probability totally mismatch is 1/2. Right, because the A has to be choose HB, the hat B, so you only have 1/2. So you will have 1/2 of the chances here. So the P2 is equal to 1/2. Okay, now let's take a look at the P3s here. Okay, P3, okay, so let's assume, okay, so now let's take a look at the P3s here. I have 3 people, A, B, and C. Now I have 3 hats. I have a hat A, hat B, and hat C here. All right. So for the first persons here, let's say here, right? So A start to choose, right? So it's all mismatch. So in case, so the A has to choose B or C, right? So how many choices A have? A have N. A have like 2 choices here, right? So A has 2 choices here. So can choose hat B or hat C, or if you write here, this is 3 minus 1s, right? So we try to derive our general forms here. So A has the 2 choices here. Either choose HB or choose HA, right? So after that, so if after the HA, choose the HA or HBs here, all right? So now I will have how many situations here? So I will have the two situations here, right? So let's see here, if the A choose the B's here, okay? So let's assume that, so if the A choose B here, so how many left here? I only have two heads left, right? So I have HA and HC. So HA and HC total is I'm going to have 2 factorial, right? Because the total numbers of the head you can choose is 2 factorial, right? Or if you want to put it into our n term, so this is 3 minus 1 factorial, right? Okay, so this 2 factorial, because it's 2 heads, totally not a match. So let me try to put so color here. Okay, so this one. So that means the probability is what? Probability 2, both of these two is not match here, okay? See here, so that is 3 minus 1, so this is the, so I will have 2 times, so I will have 2 times 2 factorial and times the P2, right? So this is my case 1. Okay, so that means if the A choose head B, then I have these two cases here, all right? So now I have another situations here, right? So this is case 1. Now I have another situation is if, so the what is this probabilities here? So this one will be, so this is total over the 3 factorials here, right? So 3 factorials, so if you, so this will be the 2 times 2 and the 3 factorial. Then P2 we got from the previous, this is 1/2. So what is here is 3, so 2/3. Okay, 2/3 times, right? So we have the 2/3 and times 2/3 here times P2s, right? This number is P2s here, okay? Then I have a case number 2s here. The case number 2s here is A choose B. So I have two different ways. A can choose B or choose C, right? As long as A choose B, so the second case is here is will be when the B choose A. So the B only have one choice here is choose A. Then the only things here were left is the C hat. So I know the C by itself, it cannot be mismatched. So you will times P1, right? So you have left P1. So that's why this one here is what? This one will be zeros, right? So, and the total is over what? It's still is over 3 factorial. So the case 2, you can simplify it to 1 over 3 P1. But since the P1 is equal to 0, so that's fine. So that's why my P3s here will be plus 1 over 3 the P1s here. And so let's see here, 3 is n, 2 is n minus 1, P2 plus this one's here because this is zeros, right? So you can just, or you can just write it, but it's fine, but this is 0. So this is 1/3 of the P1. So like in here, this is 2/3 times P2. So overall, this probability will be 1/3 here, right? Because the 2 over 3 times 1/2 is 1/3. Okay, now let's take a look. So do one more, then I think we'll be able to write out our general definitions here. Okay, so now let's take a look if I have a P4 here, right? So that means I have 4 people. Okay, so let's do this. Right, so okay, now we'll be able to see our logic here. So I have 4 people, A, B, C, D. Then I have 4 hat here, right? I have a hat A, hat B, hat C, and hat D here, all right? Okay, so the same things here. A first person, you can choose what? First person, you have an n-1 chance, right? So you have n-1. So you have 3 chance. You can choose B, C, or D. So you have 3 chance, okay? And then after the 3 chances here, okay? So how many you left here after you choose one? So let's say here, we choose one, HB again. So you have HA, HC, HD, right? So you have 3, then the total, the total way you can rearrange this will be what? Will be the 3 factorial, correct? And then this 3 factorial will be, so all these 3, we can times the probability. So let's see here which color, okay, times the probability, right? So now is these 3 will all match, will not match at all. So it's times 3. Then what is the overall total? The overall total we know is 4 factorials here, right? So if you simplify this, this is my case 1, right? This is my case 1. That means I A choose B, right? Then I have this remaining 3. Then the remaining 3, what is the probability? All the remaining 3 is not match, it's P3. Correct? So for the case 1 here, so if you simplify that, this will be what? This is so will be 3 over 4 P3, right? So this is 3 over 4 P3, then plus. Okay, so now let's take a look at the case number 2 here. Okay, I still have A, B, C, D, right? So now my hat is A, B, C, D. All right, so now here is the situations. So we said A start to choose, right? So A choose here. Okay, A choose B again. All right, so A choose B again. How many situations? I can choose B, 3 situations, right? So I have after I choose the B's, right? So it's I cannot choose myself, right? HA cannot be, so this is 3 situations. After I choose the B, then the next thing here is, well, how about B choose A's hat, right? So how about like in here, the B here, right? So here, this is my B. Wow, so the B, well, you choose the what? You choose the A's hat, right? So how many situations the B can choose A hat? Only 1 situation. Correct? There's no other, have to choose HA. Now, how many remaining? I have 2 hats remaining, right? So I have 2 hats remaining. So these 2 hats, they have a total is 2 factorial situations. And then the 2 hat mismatch is what? Is P to the what? 2, right? And then total is how many? 4 factorials here. Okay, so let's simplify this. So this is the, okay, so this is the n-1 times, so what this one will be? So this is 3 times 2, and this is 4, 3, 2, 1, right? So this is P2. That's why this one will give you is 1 over 4 P2. So that's why this one here is 1 over 4 P2. So if you want to write in the general situation, see matrix again. So this is n-1. So this is n P3 plus 1 over n P2. Now let's use the inductions here. So now let's take a look at PNs here, right? Let's take a look at the in general PNs here. So what is the situations here? Okay, so It's the same things. I have two cases here. So if you understand the P3 and the P4, then the Pn will be kind of the pretty straightforward, right? Okay, so the same thing. I have A, B, C, D, dot, 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 dot. I have to whatever, so, right? So like, let's say here, A, okay, here, maybe I better use A1, A2. So instead of A, B, C, D, so I have A1, A2, A3, A4, dot, 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 dot to AN. So the same time, I have my hat here, right? So I have the hat 1, hat 2, hat 3, da 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 to the hat ends here. Okay, so now let's do the same way. So if A1 choose, right? So what is the chance for A1 choose? Is the not match one? A1 has n plus n minus 1 situations, right? So instead of choose H1, A1 can choose n minus 1. Okay, so now let's see here. Now in here, after here, let's assume the A1 choose the H3 here, okay? So how many left here? I have n minus what? N minus 1 hat left here, right? So then in here I have n minus 1. So that's why I can choose the total. Okay, so the remaining here, I will have n minus 1 different situations here. So all this n minus 1 different situation, they're going to do the, right? So it's n minus 1 probability over the n factorial. So this is my case 1 here. So let's calculate that. So this will be n minus 1 factorial. This is n minus 1, n minus 1 factorial. Then the p, the n minus 1s, right? So here, this one is going to cancel. So that's why the first ones here will give you n minus 1 to the n to the p, the n minus 1. Good, right? So we got the first part. So this is n minus 1 to the n, and then the p, the n minus 1. Okay, so now I have a second case here, right? So the case number 2. Okay, so case number 2 is A1 choose hat 3. And when the situation, then the hat 3, the A3, which, this person choose the hat once here. They just, these two just switch. All right, so let's see what is the probability here. So for A1 choose H3 or choose any other non-H1, how many I have? I have n minus 1, correct? Then when the time the H3, right, when the A3 choose, A3 have only one choice, it has to be to the A1s here. After that, after these two switched here, right? So after they choose each other, how many I have? I have n minus 2s, right? So that's why I have n minus 2, all the different situations here. But if these two switch, what is the probability for the remaining? Is probability the n minus 2. And then the whole things here is divided by what? N factorial. All right, so now let's take a look. N minus 1 times n minus 2 factorial will give you what? It's n minus 1 factorial. Then the n, this is n minus 1 factorial, and the p, the n minus 2. And then here, dot, dot. So what is the answer? It's 1 over n, p, the n minus 2. Wow. So that's why we proved it. So plus 1 over n, the p, the n minus 2 here. This is how do we prove it, right? So remember, right, we have two cases here. One is, after you choose the A1, then you have remaining n minus 1. They are all not matched. The probability is n minus 1. How many different situations? Which one you can choose first? Second is n minus 1 factorial. right? And then here is the same way as here, right? So now the case number 2 is these two, they switch, right? So you only have n-2, then you only have a n-2 factorial, the different ways times the probability n-2. So that is how do we prove this equation. It's beautiful, right? So it's very nice equation. So it's a fun problems. All right, hope you enjoy this problem, and guess we'll talk to you next time when we do our second part here. Okay, bye-bye.